Hello everyone, welcome back to my YouTube channel Chemistry Classes. I am Rashmi. Students, in this video I will make you solve Kcet chemistry which held on 16 April 2023. Okay, this solution of this paper will help you for your upcoming exams. Okay, so let's start. Yeah, there is the first question. First question is, in Chrysoberyl, a compound containing beryllium, aluminium, and oxides ion form cubic close packed structure. Okay, aluminium ion occupy 1/4 of tetrahedral voids, and beryllium ion occupy 1/4 of octahedral voids. The formula of the compound is, okay, here given some options, as you can see that. Okay, so let's solve about it. Now, as you know that the number of atoms in CCP is, that is means n is equals to 4. Total number of atom in cubic close packing structure is 4. Now it is in octahedral void. In octahedral voids, number of atoms, that is n, it is equals to 4 also. Okay, now for tetrahedral void, number of atom, it is equals to 2n. Okay, that means it will be equal to 2 into 4, that is it's equal to the 8. Okay, so let's solve this. In this question it is said that oxide ion forms CCP, that means oxide ions have total 4 number of atom in the CCP. Now aluminium ion occupy 1/4 of tetrahedral void. If we talking about aluminium ion, it take 1/4 of tetrahedral void. How many number of atoms in tetrahedral void? It is 8. So we will multiply with 8 and the answer will be for aluminium, it is 4 to the 8. So here will be 2. Now for the beryllium ions occupy 1/4 of octahedral void. Number of atom in octahedral void is 4. So here will be the number of atom total of beryllium will be 1. Okay, that means we have one number of atom for oxygen is 4. For aluminium it is 2, and for beryllium it is for 1. So if we making the formula, we will get beryllium 1 and aluminium 2 and oxygen 4. Now our correct answer will be the second option, B, BeAl2O4. Okay, now the second question is, the correct statement regarding defects in solid is, first option, Frankel defect is vacancy defect. No, it is not vacancy defect. Second option is Schottky defect is dislocation defect. No, these options are interchanged. Okay, Frankel defect is dislocation defect and Schottky defect is vacancy defect. So both options are wrong. Third option is, trapping of an electron in the lattices lead to the formation of F center. Yes, this is the correct answer. Trapping of an electron in the lattices leads to the formation of F center. Okay, so option D is Schottky defect has no effect on density. No, this is the wrong answer. So Schottky defect is vacancy defect, so their density affected. Now the next question is question number 3, that is a metal crystallizes in BCC, body centered cubic lattice, with unit cell age length, that is A, it is given 300 picometer. If we convert in meter, then it will be 310 to the power 6 meter. Okay, now and density 6.15. okay, now let me correct one thing, that there is the not 10 to the power 6 meter, here will be 310 to the power minus 12 meter. This is the correct. And now since, as you can see that density is given, density that is in solid state density expressed by the rho. Okay, so we will write here rho. Now density is given 6.15 gram per centimeter cube. This is given in centimeter. So we will also convert it into centimeter, and it will become 10 to the power minus 10 centimeter. Okay, now it is asked the molar mass of the metal is. Molar mass of metal, as you know from the formula of BCC, this is the formula. Rho, that is density, is equals to Z into, this is the molar mass, divided by A cube, that is length, and this is the Avogadro number. This is the number of atom present in BCC, and number of atom in BCC, it is 2. Okay, now put the formula, and M will be here. Now rho, value of rho is given 6.15. okay, this is length A cube, that means 300 into 10 to the power minus 10 will be cube of third, multiplied by Avogadro number 6.022 into 10 to the power 23, and it divided by the total number of atom in BCC unit cell, it is 2. Now when we calculate this, we will find the answer 49.9, okay, which is approximately 50 gram per mole. Okay, so our correct answer will be the option A. This is the 50 gram per mole. Now the next question is, this is the Henry law constant for the solubility of nitrogen gas in water at 298 Kelvin is 1.0 into 10 to the power 5 atm. The mole fraction of nitrogen in air is 0.8. The number of moles of nitrogen from air dissolved in 10 mole of water at 298 Kelvin and 5 atmospheric pressure is. It is asked number of moles of nitrogen in 10 mole of water. So let's try to solve this also. Now here given that pressure of nitrogen. So what is the partial pressure of nitrogen? Partial pressure of nitrogen will be total pressure multiplied by mole fraction of nitrogen. From here we can calculate the mole fraction of nitrogen. So what will be the partial pressure of nitrogen? Total pressure is given 5 atmosphere, just multiplied with 5, and the mole fraction of nitrogen is given 0.8. From here we can get the partial pressure of the nitrogen gas. So it will be 4. Okay, it will be 4. Now according to Henry law, as you know that partial pressure is equals to Henry constant multiplied by mole fraction. Okay, from here we can calculate the mole fraction of nitrogen. From here now we can calculate the mole fraction of nitrogen in total. Now just put the value, that is xN2 will be, it's equal to pressure is given that 4, which is partial pressure of nitrogen. It is given as 4. Just put the values 4, and value of Henry constant is given in the question. This is the 1.0 into 10 to the power 5. Okay, from here we will get the value 4 into 10 to the power minus 5, value of this X nitrogen. Okay, now as you know that from the question, 1 mole of water, that means we will get the value 1 mole of water contains this 4 into 10 to the power minus 5 moles of nitrogen. Okay, then how many moles, then 10 moles of water will contain, 10 moles of water will contain, it will be 10 into 4 into 10 to the power minus 5, and this value will be equal to the 4 into 10 to the power minus 4. Okay, so our answer will be 4 into 10 to the power minus 4. That is the correct option A. Okay, so our correct option will be A. It will be equal to the 4 into 10 to the power minus 4. Okay, Now the next question is our our next question is, a pure compound contains 2.4 gram of carbon, 1.2 into 10 to the power 23 atoms of hydrogen, 0.2 mole of oxygen atoms. Its empirical formula is, okay, so let's start. First of all, we calculate the number of moles. From the number of moles we can find the amount of the elements in this empirical formula. So number of moles of carbon, here given that the compound contain 2.4 gram of carbon. As you know that the number of moles is equals to mass of the substance and divided by molar mass of the substance. Mass here, mass of carbon is given 2.4 and we divided with molar mass of carbon. Molar mass of carbon is equals to 12. When we calculated, we found that 0.2 moles. Okay, now the number of moles of this hydrogen atom, okay, it will be equal to, for hydrogen here given that in number of atoms, and you know that number of moles is equals to the, in the terms of atom, it is equals to number of atom divided by Avogadro number. Now you can put the values 1.2 into 10 to the power 23 and divided by Avogadro number, that is 6.022 multiplied by 23, and you will, when you solve this, you will also find the value 0.2 moles. Okay, now here one is more element, that is the oxygen. Now the number of moles of oxygen will be here given for oxygen directly 0.2 mole. Now you can see that there is number of moles are equal in all elements, so number of moles are equal, so our formula will be equal, that is it will be CHO. They have equal numbers of moles in their formula. If just suppose anyone have a different number, then we multiply it by a suitable number and make the number of moles equal to each other, then according to them we will write the same empirical formula. So here our correct answer will be the option D. Okay, that is the CHO. Now the next question, choose the correct statement. Okay, now first statement is Kh, that is the Henry constant value is same for a gas in any solvent. Okay, no, this is not correct, it is not same. B, higher the Kh value, more the solubility of gas. No, it is just opposite. Kh value increases on increasing the temperature of the solution. Next is easily liquefiable gases usually has lesser Kh values. Okay, our correct option is the C, that is the Henry constant is directly proportional to the temperature. If we increase the temperature, solubility of solution will be of gas in liquid will be decreases. Okay, so if we increase the value of Kh, solubility automatically of gases in liquid will be decreases. So all these value are wrong and correct option will be C. Okay, now the next question is the Kh value, that is Kh value of argon and carbon dioxide, and third is formaldehyde and methane are respectively these. The increasing order of solubility of gas in liquid as I told you, that is if Kh value increases, solubility decreases. So whatever the compound or element which have low value of Kh, their solubility will be increases. Okay, their solubility will increases. So which one have Kh value, less Kh value? We can see that this one have less Kh value and it is of this formaldehyde. That means third will have more solubility because it has less Kh value. After that, this is this 0.413 which is of methane. So next is the fourth option, it have less than this, and after that there is 1.67, it is of carbon dioxide, that is second, and 40.3 it is the more for the argon, that is for the first. So our in among these compounds, third one, that is the this one have low value of Kh, so their solubility will be highest. And in the question we ask the increasing order of solubility of gas in liquid. So if we arrange in increasing order, then this will be the increasing order of the solubility of gases. So according to this, our correct option will be A. Okay, now the next question we asked, the vapor pressure of pure liquids A and B are 450 and 750 mmHg at 350 K respectively. If the total vapor pressure of the mixture is 600 mm of Hg, the composition of the mixture in the solution is. Let's solve. Okay, in the question here is given that vapor pressure of pure liquid AB, vapor pressure of pure liquid is shown by P0 A, and it is equal to 450 mm of Hg. Okay, now for pure liquid for PB, it is given 700 mm of Hg. Okay, if we and also here given that total vapor pressure of mixture, that is PT, it is equals to 600 mm of Hg. Okay, now we know the formula, that is from Raoult's law. From Raoult's law, you know the formula, that is Pa is equals to the, that is pressure of impure solid, that it is equals to the Pa, that is P0 A multiplied by mole fraction of A, and Pb is equals to mole fraction of B. Okay, now what will be the total pressure? According to Dalton's law, it is the total pressure of all A and B, that is total pressure is equals to pressure of A and pressure of B. Now just put the values in it. Pa have the value. Okay, Pa just here you can see that Pt is equals to Pa. Pa have the value P0 A multiplied by mole fraction of A plus Pb, that is P0 B multiplied by mole fraction of B. Okay, now just solve this. You can write like this: P0 A multiplied by XA plus P0 B multiplied by as you know that XA plus XB is equals to 1, so you can write here XB is equals to XA 1 minus XA. Okay, you can write it also. To solve the question, just put the values like 1 minus XA. Now put the values. P0 A have the value 450 multiplied by XA. Here we don't know the value of XA, so we try to calculate it. Now the value of PA will be put here, 700 minus 700 XA. Now when you solve this, and here the value of PT is given 600. Now when you solve this, you will find the value of XA. It will be equal to the 0.4. Okay, now from the formula XB, you will also get the value of XB from this formula, 1 minus XA, that will be 1 minus 0.4, and the answer will be 0.6. That means the value of XB will be 0.6 and XA will be 0.4. So our correct answer will be option A. XA is 0.4 and XB will be 0.6. Okay, now the next question is the consider the following electrodes. Here given the values of some electrodes and asked electrode potential of the above electrodes in volts are in the order. Okay, now let's solve. Okay, as we know from the Nernst equation, that is it is equals to E cell is equals to E naught cell plus 0.0591 divided by n log 1 by mn 2 plus ions. Okay, here it is given that E naught. Okay, here given that E naught, here not the plus, here is the minus sign, E naught cell minus sign. We can write it also like this: E cell minus 0.0591 divided by n log m n 2 plus. It will be minus when we write like this, then there will be plus sign will be, okay, because minus 1 when get upside, it will be just opposite, and there will be plus sign will occur. That means E naught cell, that means lower the concentration of Mn plus, lower is the E. That means now you can see that it is directly this E cell is directly proportional to the concentration of metal ion. Okay, that means E cell, from the equation you can see that it looks like E cell is directly proportional to the Mn, that means metal ion. Okay, that means if E cell is high, then concentration of Mn plus high. That means if concentration of Mn plus high, then E cell, value of E cell also high. Here the value of E cell is given. For P, it is given 0.0001. That means we can write like this, 10 to the power minus 4 for P, and for Q it will be equal to the 0.1, or you can see that now for R you can see that it will be 1 into 10 to the power minus 2, and for S it will equal to the 1 into 10 to the power minus 3. Now you can write this also 1 into 10 to the power minus 1. Now you can see that there are PQRS, the value which have lower concentration, because which have lower concentration, they will have the lower value of E cell. Which have higher concentration, they will have the higher concentration of E cell. Here Q has the higher concentration, as you can see that when we arrange them according to their higher concentration, we will find the value, that is Q will have maximum value. After that, this is the R, and after that there is the S, and very low concentration of low concentration have by the P. Okay, this is the value of, this is the order of concentration of metal ion. And as I told you, concentration of metal ion will be high, then E cell also will be high. And we ask potential of the above electrode in volts in order R. Simply the concentration high, E cell also will be high. So this will be the order of E cell also. Okay, so in this options our correct answer will be option C. Okay, now let's see the next question. Next question is given: the number of angular node and radial node in 3p orbitals are respectively. Okay, for the angular node, the angular nodes are equal to the azimuthal quantum number, that is it is equals to L. And for radial nodes are equal to the main quantum number, that is principal quantum number, minus L minus 1. This is the formula for the radial nodes. Now calculate the angular node, which is equals to L. As we know that L have value 0, 1, 2, 3. 0 for S, 1 for P, and 2 value for D, and the value 3 for the F. Now here given that 3p, P for the 1, for P the value of L will be 1, so here angular node will be 1. Okay, now what is for the radial node for n minus L minus 1. As you know that n will be equal to the 3. This is the main shell, that is principal quantum number. Value of n is the 3. Now put the value, and L is given that 1 as we calculated here. So radial node will be 3 minus 1 minus 1, that it is also equal to the 1. So radial node is 1, also 1, and angular node will also be 1. So our correct answer will be option B. Now the next question is the resistance of 0. Here given that one minute. Resistance of 0.01 m KCl solution at 298 Kelvin is 1500 ohm. If the conductivity of 0.01 m KCl solution is 298 Kelvin, 0.146 10 to the power minus 3 s per centimeter, the cell constant In this question asked, the cell constant of the conductivity cell in per centimeter is. Just put the formula and calculate the value. Okay, as in the question, resistance is given 1500 ohm and conductivity, just suppose conductivity is K and it is given 0.146 into 10 to the power minus 3 s per centimeter. Okay, now and temperature is given 298 Kelvin. Now use the formula, that is equals to conductivity is equals to the Z into X. What is the X? X is the cell constant which is asked in question, and G is the value, that is the reciprocal of R, that is resistance. G is the reciprocal of R. From this formula we can solve our question, and this is the conductivity. Now for the X cell constant, we have to calculate the cell constant. So X is equals to will be K by G, and G is equals to 1 by R, that is it is the reciprocal of R. So we will put the value, we will find that conductivity divided by multiplied by R. Just put the value of both these, 1.4 into 10 to the power minus 3, and value of resistance is 1500. Okay, when we solve we get the answer 0.219 per centimeter. So our correct option will be option A. Now the next question is, hydrogen plus silver chloride, when react they forming silver and hydrogen chloride. Now E cell at 25 degrees Celsius for the cell is this, and the equilibrium constant asked, equilibrium constant at 25 degree Celsius. Simply for this we will use the formula of E cell is equals to 0.00591 divided by n log K. Okay, this is the formula in which this E naught cell related to the equilibrium constant log K. Okay, just memorize all formulas. Okay, we will use this formula here. Now put the values just like 0.0591, and here is the n. Here is the value of n will be here n have the value, and factor value will be, as you can see that Az here get converted into Az 0. Here will be the value of Az is plus 1. Okay, and here will be the 2 multiplied by 2, so total number of change in electron will be 2, and this is the n factor, that means total number of electron interchanged are it is equals to 2. So we will take the value of n factor is 2 and just write here that is the log k. What will be the value of log k? Just this will be equal to the k into antilog 0 point antilog not 0 point, it will be antilog n factor e naught shell multiplied by 0.0591. Just put the values like antilog value of n is 2, total 2 number of electrons are changed, value of e naught cell is given 0.22 and just divide it with 0.0591. We will get the answer, that is anti-log 7.44. its value given maybe in your exam or log table will be given. Okay, the value of k will be 2.8 into 10 to the power 7. Okay, so our correct answer will be A. Next question is the our next question, for a reaction A plus 2B products, when concentration of B alone is increased, half-life remains the same. If concentration of A alone is doubled, rate remains the same. The unit of rate constant of reaction. For the to find out the unit of rate of constant for the reaction, first we have to find out the which order of reaction. Okay, so just find out how the which order of reaction. As you know that in this question said that when concentration of B alone is increased, half-life remains the same. As you know that the for first order reaction, that is the it is equals to T half-life for first order reaction, it is equals to 293 divided by K. That means first order reaction is independent of the concentration. That means order of reaction of B with respect to B will be 1. When here just said that when concentration of B alone is increased, half-life remains the same. Okay, so we can say that order of reaction with respect to B, that is order of reaction with respect to B will be 1, because when we double the concentration of B, there is no half-life remains the same, that is there is no change in the concentration of other. So next said, if concentration of A alone is double, rate remains the same. Okay, if concentration of A also increase, that means if we double it, that means the rate remains the same, that means this rate also remains the same. That means if we double the concentration of A, this rate constant also doubles, so their rate remains the same. That means this is also the first order reaction. Okay, with respect to A, order of reaction will be also 1. Okay, because in first order of reaction, concentration is proportional to the rate of reaction. Okay, it is proportional to the rate of reaction. In first order reaction, if we double the concentration of A, then rate will also be double. If we triple the concentration of A, rate also will be triple, because rate is directly proportional to the one concentration of A. Just it is also simply implies that rate of reaction of A with respect to A, rate of reaction also will be 1. That means A is also have a rate of reaction order of reaction 1 with respect to B, and B also have a first order reaction with respect to A. That means if we add them 1 plus 1, it will be 2. That means the total order of reaction is the 2. Okay, for the 2, unit of the rate constant for the second order reaction will be liter per mole second. Okay, let's discuss the question number this. For a reaction A plus 2B products, when concentration of B alone is increased, half-life remains the same. Okay, if the concentration of A alone is double, the rate remains the same. The unit of rate constant it is asked in this question. Just think that when concentration of B increased, okay, then that is T half remains the same, not change in the half-life, and it is possible for the first order reaction, as you know. Okay, in first order reaction you know that half-life does not change by changing in the concentration, because half-life is independent of the concentration for the first order reaction. It means that with respect to B it is first order reaction. Okay, with respect to B, when B increased, half-life remains same. With respect to B, this will be the first order reaction. Now in the second part it said if concentration of A alone is double, if it is double, then the rate remains, as you know that concentration is proportional to the rate constant, rate remains the same, there is no change on the rate. That means this is if concentration is not affected by changing concentration, that it will be the zero order reaction. Zero order reaction, this will be not depend on the concentration. So that means with respect to A it will be zero order reactions. Okay, just add them, 1 plus 0 it will be equal to the 1. That means for first order it is the first order reaction. And as you know that for the first order reaction the unit will be per second. Okay, so our correct option will be A. Now the next question is, the third ionization enthalpy is highest in, it is highest in third ionization energy, it is highest in, as you know that, alkaline earth metals. Okay, as you know that in alkaline earth metals nitrogens are nitrogen family and chalcogens are the oxygen family. Okay, now why is it is highest in alkaline earth metals? Just suppose this is the magnesium element of alkaline earth metals, it have atomic number 12 and that it have electronic configuration like this, 2sp 2p6 and 3s2. Okay, now when two electrons are removed, but when we remove third electron it will be the completely filled orbital, and you know that completely filled orbitals, that is half filled and completely filled orbitals have the most stable configuration. Okay, most stable configuration, and they have the highest ionization energy. Here when you compare all, you find that alkaline earth metals have the highest ionization enthalpy because it have completely filled orbital, that is 2p6, and nitrogens like nitrogen, when you it have atomic number 7, when you write its electronic configuration you will find that 2p3. Okay, if its first ionization will be highest because it have half filled orbitals, but the second and third will be less. Okay, similarly it will happen with the alkali metals also and chalcogens also. Okay, second ionization of alkali metals are highest. Just think that what about asked, it asked third ionization, it will be highest in the alkaline earth metals. Next question is given that the rate constant for first order reaction K is the time required for the completion of 99% of the reaction is given by. Okay, rate constant for the first order reaction, as you know the formula for the first order reaction, that is Kt is equals to the 2.303 log A 0 by A, where A is the initial concentration and A is the final concentration. In the question given that A0, that is initial concentration, will be 100%, and what will be the concentration of A, as in the question here given that completion of 99% of the reaction, that means 99% completed. Okay, 99% are completed, so that remaining 1% is remains, that means the value of A will be 1 Just suppose, okay, if if initial concentration is 100, then after completion of 99% the concentration of A will be 1. Just put these value in the formula and you will find the answer. Kt is equals to 2.303 log A0 is given that 100 and value of A will be 1. Okay, when you solve this you will find that you will able to find the value of T. Okay, T will be 2.303. This will be, you can write that 1 into 10 to the power 2, that means it is log 10 to the power 2, which can be written as here given in the terms of T, so we will also write in the terms of T. 2.303 multiplied by 2, 2 will be here, log 10 have value 1 and it will be K, and you will find the answer 4.606 by K. Okay, so our correct answer will be A. Okay, now the next question is, the rate of gaseous reaction is given by the expression KAB square. If the volume of vessel is reduced to 1/2 of the initial volume, the reaction rate compared to its original rate will be. Okay, so in this question said that you know that concentration is equals to the number of mole divided by volume. As you can say that concentration is inversely proportional to the volume. Here in the question said that if the volume of vessel is reduced to 1/2 of the initial volume. In this question said that if volume is reduced to 1/2, okay, that is 1/2 to the initial volume, the rate of reaction comparison to the other. Okay, so let's try this question. As you know that concentration will be inversely proportional to the volume. Okay, and in this question said that volume is reduced to 1/2. If we reduced volume to the 1/2, that means if we did this V by if we do this like 1 by V by 2, then what will happen? Here will be 2 by V. Okay, this will be the concentration. Now here in the question given that K, a concentration of A and concentration of B. Okay, it will be, now you can see that if we reduce volume to the half, then concentration will be doubled simply. Okay, in this question here said that if the volume of vessel is reduced to 1/2 of the initial volume, it means that concentration of the reactants will be doubled. These are the reactants, concentration of reactant, that means R is equals to given A and this will be B square. If we reduce the volume half, then concentration will be double. Just that means value of A will be double and value of B also will be double. Then the what will be rate of reaction compared to the original rate will be, it will be 2 into 4 and it will equal to the 8. That means it will be 8 times of the initial rate of reaction. The correct option will be C. Okay, just simply remember that concentration is inversely proportional to volume, and if we remove, just suppose if we reduce the volume as 1/4, then concentration will be 4 times increases. Here in the question volume reduced to 1/2, so concentration will be 2 times greater. Just put the value of concentration in these two and we will get our answer. Okay, here given that next question, the correct IUPAC name of this compound is. Okay, you can see that nitro group is preferred, then there is fluorine group and there is the ethyl group. Just naming the according to their alphabetical orders. This is the nitrobenzene. Okay, if we go through the alphabetical order, then ethyl will come. If we go through the priority order, fluorine will become first. Okay, so priority will be given to the fluorine. Okay, that means among the fluorine, and this is ethyl group, fluorine is given to the priority. okay, from this ethyl group. Okay, now we can keep just numbering in this nitrobenzene. This will be numbering will be 1 2 3 4 5. Okay, so name will be the 4 alphabetically. Ethyl will come, okay, and fluoro will be come after the ethyl. So 4, it will be 4 ethyl, 1 fluoro, and fluoro nitrobenzene. Okay, sorry, there is the mistake. Okay, just make it clear first. That is, here is the group fluorine, nitro and ethyl group. Okay, nitro group, fluoro group, and there is the ethyl group, C2H5 group. Now we put the numbering in the benzene ring like that which have lowest in the numbering. If we start numbering from here 1 2 3 4 5 6, we get that 1 plus 2 plus 4. Okay, and if we start from here, we can find that 1 2 3 1 2 3 4. That means 1 plus 3 plus 4. Okay, and it have sum is equals to 8, and it have the sum 2 plus 3 and 7. One more way to give the numbering, that is 1 2 3 4 5 6, and it will be 1 plus 6 plus 3, it will also 10. So lowest numbering is the this, which we got that 7. So we will give the numbering from here 1 2 3 4 5 6. Okay, according to this, just put the name with alphabetical order. Ethyl will come first, so ethyl have the position 4, so 4 ethyl, and 1 fluoro, 2 nitrobenzene. Okay, this will be the name, so correct option will be A. Now the next question is, higher order, that is greater than 3 reactions are rare due to it is because shifting of equilibrium toward reactant due to elastic collision, loss of active species on collision, low probability of simultaneous collision of reactant species, increase in entropy more than it involves. Okay, so correct option will be C, low probability of simultaneous collision of reacting species. Okay, as you know that molecularity of reaction, that is higher order, which will be greater than 3, is rare because low probability of simultaneous collision. Okay, next question, arrange benzene and hexane and ethyne in decreasing order of their acidic behavior. It will be the correct option D, ethyne are more acidic than benzene and hexane. Just remember this order. Next is the a colloidal solution is subjected to an electric field, then colloidal particles move toward anode. The amount of electrode, that is BaCl2, AlCl3 and NaCl required to coagulate the order of given colloid is. Order of given colloid will be, as you know that BaCl2 produces Ba2 plus ion, AlCl3 produces Al3 plus ion, NaCl3 produces Na plus ion, and order will be the which have more charge, they bring the more coagulation. Okay, this is Ba2 plus and this is Na plus. Okay, which have a small size, they bring the more coagulation. Okay, here for the coagulation, the correct order will be option D. Okay, next is the which of the following is an incorrect statement. Hydrogen bonding is stronger than dispersion force, sigma bond are stronger than pi bonds. Here asking about incorrect statement. Ionic bonding is non-directional. Sigma electrons are referred to as mobile electron. The wrong answer will be the D. Okay, sigma electrons are not mobile electron, only pi electrons are mobile. Here asked zeta potential is potential required to bring about coagulation of colloid solution, potential required to give the particular speed of 1 centimeter, potential difference between fixed charge layer and the diffuse layer having opposite charges, potential energy of the colloidal particle. Okay, correct option is C, it is the potential difference between fixed charge layer and diffused layer having opposite charges. Okay, These are the questions. Other questions I will discuss in my next video.